Welcome to Study Loop.
This is problem 120 of Chapter 7 of Vector Mechanics for Engineers, Statics, and Dynamics. So in this problem, there is a cable going from A to E. There's a load applied downward at B of 2 kilonewtons, downward at C of 4 kilonewtons, and downward at D 6 kilonewtons. The horizontal distance from A to B is 5 meters. The horizontal distance from B to C is 5 meters, C to D is 5 meters, and D to E is also 5 meters. The vertical distance from A to B is distance B. The vertical distance from A to C is distance C. And from A to D is distance D. And we are given in the problem that the tension in the cable is 25 kilonewtons. So the first thing you're going to do is draw a free body diagram of this cable from A to E. We can include the reaction forces at A. AY is in the positive Y direction, and AX is in the negative X direction. And the reaction forces at E. EY is in the positive Y direction, and EX is in the positive X direction. So we can do the sum of moments around A and set equal to 0. This is negative 2 times 5, because there's 5 meters in the horizontal direction between A and B, minus 4 times 10, because there is 10 meters in the horizontal direction between A and C, minus 6 times 15, because there's 15 meters in the horizontal direction between A and D. And we can add a EY times 20, because there's 20 meters in the horizontal direction between A and E. We can completely solve for EY, which is 7 kilonewtons. We can also take the sum of forces in the Y direction and set equal to 0. This equals positive AY plus EY, then subtract all the downward forces. We can solve completely for AY now, which is 5 kilonewtons. Also, we can take the sum of forces in the X direction and set equal to 0. And this equals EX minus AX. So we know that EX is equal to AX. Next, we can draw a free body diagram from D to E. And we can solve for the tension DE, which is equal to the max tension, which was given in the problem to be 25 kilonewtons. We can use the formula EX squared plus EY squared. And because we know Tmax and we know EY, which we already solved for above, we can solve for EX. So EX equals 24 kilonewtons. There are a few ways we can go from here in the problem. We can solve for all the shear forces and then the bending moments, but I'm just going to go ahead and jump to solve for the bending moment around C. So the bending moment around C equals AY times 10, because there's 10 meters in the horizontal direction between A and C. I'm going to subtract the force at B, which is 2 times 5, because there's 5 meters in the horizontal direction between B and C. Therefore, the bending moment at C equals 40 kilonewtons times meter. From problem 119, we know that MC equals T naught times H, but in this problem, MC will equal T naught dc or EX dc, because in this problem, T naught is EX. So therefore, we can plug in the known values, because we know that MC equals 40. We know that EX is 24 times DC, which is what we were trying to solve for. So DC equals 1.667 meters. This is the final answer for the problem, the distance of C.